Statsproblems.com was used to create this tutorial, which can help us calculate the area between two means in a sample mean distribution. Let's begin by selecting one of the 25 example problems. The question appears in the blue box. A set of scores is normally distributed. Population mean, mu, is 24. Standard deviation of population scores, sigma sub x, is 12. Sample size, n, is 25. In a sample mean distribution, what is the proportion of means between a mean x bar 1 of 22 and a mean x bar 2 of 27? Let's step through the solution by clicking on the Next Step button. In Step 1, we calculate the standard error of the mean. The standard error of the mean, sigma sub x bar, is equal to the standard deviation of the population scores, sigma sub x, divided by the square root of the sample size, n. In this example, the standard error of the mean equals 12 divided by the square root of 25, which works out to 12 divided by 5, which works out to 2.4. In Step 2, we calculate the z-score of the lower mean. The z-score equals x bar 1 minus the population mean, mu, divided by the standard error of the mean, sigma sub x bar. In this example, the z-score equals 22 minus 24, divided by 2.4, which works out to negative 2 divided by 2.4, which works out to negative 0.833. Our table uses z-scores with 0.05 between entries, so we round the z-score of negative 0.833 to negative 0.85. In Step 3, we calculate the z-score of the higher mean. The z-score equals x bar 2 minus the population mean, mu, divided by the standard error of the mean, sigma sub x bar. In this example, the z-score equals 27 minus 24, divided by 2.4, which works out to 3 divided by 2.4, which works out to 1.25. In Step 4, we find the area between the two z-scores. To find the area, we use Table 5, finding areas under the normal curve between z-scores. First we click on the entry for z equals negative 0.85, which highlights in blue the area of 0.198, which is the area below the lower z-score of negative 0.85. Next, we click on the entry for z equals 1.25, which highlights in green the area of 0.106, which is the area above the z-score of 1.25. The area between the z-scores in pink is 1 minus the area below of 0.198 minus the area above of 0.106, which works out to 0.696. We close this window to return to the analysis, which shows the lookup table with the below area of 0.198 and the above area of 0.106 and the area between of 0.696. With a population mean of 24 and a population standard deviation of 12, and a sample size of 25, the area between a mean of 22 and a mean of 27 is 0.696. In addition to the 25 example problems, we can work step by step through an unlimited number of new problems using the Generate button. The Edit Data button can help us create problems with customized input. Instructors can use this function to create problems with complete solutions to use on exams, in class, or for homework. For printed output, we can print the question. Or we can print the question with the complete solution. The free website has statistical analyses in all of the most common areas in statistics. Statsproblems.com also has a mobile version so you can access the site from anywhere. For help with statistical concepts, HelpMeWithStats.com is a free website that has more than 70 tutorials, as videos, or as self-paced slideshows. In addition, HelpMeWithStats.com gives you free access to a comprehensive stats textbook with more than 685 review questions. Thanks for watching. If you find these resources valuable, please share statsproblems.com and helpmewithstats.com with your friends and instructors.